Hello, everyone, and thank you for joining the Tooling U-SME webinar today on robotic safety. You will notice on your screen there is a Q&A box. If you have any questions for the speaker today, you can go ahead and enter them there, and we will try to get to them today before the end of the webinar. And I would like to introduce you to our speaker today, Herb Pierce. Take it away, Herb.
All right. Hello, everyone, and thanks for joining us today. I know last week, some of you that were with us, we didn't get a chance to answer some of the questions you guys had. We will try our best to get to them before the end of today to get them emailed back to you. But again, we're starting part 2 of our series of webinars. Now we're going to have a total of 4 with what we didn't finish in the first session. We added on to the backside of what we have. So again, we talked about last week of the intro to robotics. We moved the applications to part 4 because there just wasn't enough time. But today we're going to focus on robotic safety. And we're going to hit it from probably about a 1,000-foot level. When you say robotic safety, there's many topics that could be added into robotic safety that can go into great detail and take quite a bit of time. So out of today's webinar is basically just to kind of open your eyes to just give you information to take back for some homework, whether you're maintaining an existing system or you're thinking about building a new system or you just want to know more about robotics. The safety part of this is very, very important. We're going to see the difference between the cobot world and between the traditional, conventional industrial robots. And then, of course, next week, we're going to go into maintenance and troubleshooting. And then finally, on the 4th week we added on will be the applications. So where does safety begin? I know you may see this a lot in industrial environments or in your institutional education, where it talks about where does safety begin? The safety begins with you. So when we talk about a robot cell, and we're going to take a picture of, we're designing a brand new system, or maybe a system has been designed and you're ready to qualify it, you're ready to bring it into your factory or into your school, we have to take a look at where does the safety part begin? Well, that begins with the assessment in the design phase. With that, it also takes into the risk assessment. You want to understand what hazards are in place, what things need to be mitigated, and what can you do to put these policies in place and or safety fixtures and features to allow the operator and even the robot to work within the safe parameters that they are. And of course, safeguarding technologies that we can implement, whether if it's a physical barrier, presence sensing devices, safety interlocks that protect the operators. And then the most important when it comes to safety is training and maintenance. We can have all these features installed, but if the operators and the maintenance team that takes care of these systems don't understand how they operate, bad things can happen. The system can get destroyed by people not understanding how to work it, or the operators may be operating in an unsafe way. Or even the maintenance people, sometimes they may be challenged and they just don't understand how things work. And that's where safety is very, very important. So some of the robot components. So when we look at even cobots, depending on what the risk category may fall into by doing your safety assessment, may even require some type of fencing. You will always see with a conventional industrial robot a fence. So the fence pretty much is a typically used around, we call it a cell. People may hear mention that. Prevents people from entering. This is an area that's significant in features because it makes the robot separated from the person so they can't be injured. When setting up this cell, they need to be understanding that there are certain parameters that need to stay in place. Sometimes light curtains can be used. And then also many safety features need to be taken into effect when that is done. Right here is the components of a robot cell. So a robot cell in its completed nature has these peripheral systems. Now, according to OSHA, we're not going to dive deep into this, but if you look at OSHA 29, and of course the CFR they have known there, it's called commonly known as the lockout tagout system. So if you can look at this image that I have here on the screen, within that cell where the robot is sitting, you see the safety fence, you see the controllers, kind of get a good picture of where things are. If you are standing within this robot system, you must have it locked out. Unless you're a trained individual, that a lot of robots come with what's called teach pendants. And those teach pendants have like dead man switches, have other peripherals and other things in them that allow for you not to, if a situation comes up, you can either hit the e-stop, or if you squeeze really hard on the dead man switch, the robot will come to a complete stop. These systems have to be in effect in order for you not to be hurt, or the maintenance personnel or things like that. Now, depending on the facility or where you are, depending on who you're working with, what company, there may even be parameters in place where the company doesn't even allow you to be in the cell, even with the teach pendant. So these are things that you must be aware of. Again, I'm not going to tell you either way whether you can or cannot be, but these are some different things that we've seen in the industry. However, we should always stay with the rule of thumb to always be safe. And those safe matters are basically to, when you're in that robot cell, that you must have that system locked out. So, of course, we're following OSHA. So, and these are to protect the individual so that they're not getting hurt. Some of the tools for safety are things of emergency stops. Now, emergency stop does not take the place whatsoever of a lockout tagout system. We also have the lockout tagout system. So if you're working on something from a maintenance standpoint, or you're clearing the jam out, then you have to have that lockout tagout system in place. You also have your teach pendant, which, if those of you who haven't seen one before, the third one in is to complement to FANUC America. And with this teach pendant here, you can see on the back side of it the two yellow grips. Those yellow grips allow for you to hold them, and while you're in there and the teach pendant is active, that you must hold these in order to walk into the cell and be able to manipulate and move the robot. Now, if an integrator or a person that's designing the robot system is there, they sometimes have to get close to these fixtures to be able to, quote unquote, jog the robot. And that might be a term we haven't gone over before, but if you must move that robot to a certain position, you have to use this teach pendant to get there. And sometimes it has to be within 10 millimeters of that fixture. So that may be needed in certain circumstances. Again, you'll have to go into the safety parameters and safety features of what your plant specific or organization specific standards are when it comes to safety. But these are things that you must know that are available, but may or may not, or can or cannot be used depending on your environment. Now, third of all, there are some scenarios, and we'll go into this just a little bit, to where if you're going in and clearing a jam per se, or you're just reaching like your arm in to move a slip sheet from outside the parameter, and the system was made that way, there may be things installed such as a laser scanner or light curtains. Light curtains I've typically seen with pallet conveyors, to where there's no door, but there's an opening, and you have an emitter curtain and you have a receiver curtain. And as the pallet transfers through, it has sensors, or may look at the interlock of the motor, will then mute the light curtain to allow the fixture or the pallet to pass through without shutting the system down. You can also do the same thing with light scanners that allow you to maybe reach in and change a part. Maybe you're working in the machine environment where a part has to be put in and taken out. So while that light curtain's being blocked, that system is being told to pause or to stop, but not necessarily trip under a safety unless one of the safety rules of that logic is violated. So these are all custom things. Now, the light safety scanner works in places to where sometimes the robot says, okay, I see the presence of a person standing here. These light scanners and light curtains can be programmed to say, okay, the robot will avoid and will not go past this designated zone because there's something occupying it, whether it be a human or not, and that zone will not allow that robot to move over that position. I've seen those commonly used, and we'll see why that is specifically allowed. With the next slide, we're going to look at the machine safety standards. So there are some things that we're going to go talk about a little bit from the safety standards, whether if it's ANSI or ISO. We're not going to dive deep into these. If you guys are very interested in these, I would contact Tooling U, and you can ask them, and we can put together a webinar or even a class that dives deep into some of these topics, because these topics alone could take hours to get into. So when it comes to machine safety standards, you have to have things set up, of course, as a position for lockout, tagout, when you have to remove the sources of energy, whether if it's pneumatics, Robots typically won't see hydraulics, but maybe the EO for some reason might have one. But of course, from the electrical energy to keep the personnel safe around working with that robot. Of course, all this goes with a risk assessment, and it comes with a risk score. So a lot of times when you're working with equipment that may be involved with Canada or China, they follow a European standard. In the US, you'll typically see where they'll follow an ANSI or ISO standards. So a couple of them that I called out so that you could see is ISO 10218-1 talks about robot safety devices and requirements for industrial robots. If you look at the Canadian standard, that's CSA-Z 43403, where it talks about how it applies to the manufacturing, the building, and the installation, the safeguarding, and repairing and test starting up of personnel and the requirements that are utilized for this. So one of the Canadian standards, if I would go back to the fence page, they will actually specifically go to the robot fence and saying, how large can the squares be so you can fit your fingers through there in the event the robot passes by? How far does the robot need to be away from the conveyor system? So if you're designing a system, those are things to be aware of. Like when the robot passes through, okay, if the EO is going to pass next to the safety fence, then that may be something you have to make the fence wider because of that hazard. If there's an area where you might see here, there's 2 pallet stations to the left and to the right. So there are light curtains that are placed there. You see that single line going through there. Well, if the robot, in this case it doesn't, but say it did, that robot space needs to be so big to where if a person were to trip and fall into that zone, the robot still had enough stopping time to where it could not reach to the human. So those are things to keep in mind when you're designing these systems. Again, here's an example from Federal that you see in the photo of a lockout tagout. They're just locking out the fence. Now, I know Federal does this, that when somebody opens the fence to go in and clear out a jam, there are other safety systems that are in place. Specifically, I know FANUC, to where the safety relay that's tied into the fence is also tied into the safety relay of the robot. So if that fence is open, some factories may require you to put a lock on the door handle. So while that you're in there, you can't then, somebody can't go behind you and close the door and start the system and lock you in there. So this, by the handle being down, the lockout hasp being open, you can lock the fence. Other factories, depending on what the risk mitigation is of the risk score that they may have done, may require you, no, before you pass over the threshold, you must then lock out the robot. But that also opens up other things to be looked at as well. In some cases, factories may look at the risk mitigation to where you have the door open, you lock the hasp, and there's a safety scanner seeing if somebody's within the cell. So those are all things to keep in mind. Again, going on with machine safety, you have ANSI R15 talks about industrial robot safety requirements, designing and operating the cell. You have ANSI R506 that talks about the 3-step process. The 3-step process to the right-hand side talks about eliminating the hazard, safeguarding and preventing the operator from coming in contact with the hazard, then bring it to a safe state so the operator can go in there. And then supplementary measures such as warning signs, training, and personnel protective equipment when going into working with these machines. So those are things that you need to be aware of, that there are ANSI standards out there that talk about how to keep your operators safe. Now, we talk about the risk mitigation, the risk assessment. This here's an example that came from ANSI that talks about what is required. Well, it talks about naming the hazard, the description of what's going on, the severity, the exposure. So when you look at how far of a risk or a hazard is this, they're going to look at what is the probability of the occurrence that's going to take place. How often do you expect this to take place? What is the maximum loss, not to the product, but to the human? And then how many people are affected by this? And that all comes back with a certain score that goes to the severity and harm of the probability calculation. We'll go into this chart. Next, what they'll also do is they'll look at the risk reduction. So you get a number, and once you get that number, they'll take and then they'll do a calculation based upon the risk reduction, which you can find in ANSI B11. These are things that I recommend you guys download the PowerPoint slide here and do your homework and understanding like what's going on here. So you can take the combined information found from many different sources of the safe distance calculation, the reaching distance. So we talked about the holes in the fence, or maybe have something designed where somebody can grab some slip sheets and pull them out, or they have to put a fixture in. How far is their reach? How high is the fence? What the design of the guard construction are? Or how are the gaps in the opening of the sizes? Do they have whole body access? Do they have muting? And I'll talk about muting in a second. Is there bypassing? And what safety devices are involved? So whole body access, again, like I talked about, if the door is opened up, they can walk in. If there's a light curtain, they can walk in. So a lot of times I would recommend, if you're utilizing a light curtain, you should also use a line scanner, because a light curtain just looks at the threshold. You walk through the threshold, the light curtain doesn't know which side you're on, unless you have a vertical and horizontal curtain. But then you might as well look into getting a safety scanner, because you can make that scanner set up in a way to where it knows the fixtures of the environment and can, usually it's mounted closer to the floor to where you can see, or the scanner can see where you are. So those are things that take an effect. Now, the word muting comes in effect, especially when it comes to maybe there's certain conditions within the safety scanner. Maybe there's certain conditions, like I talked about, the pallet passing through. So when the light curtain is blocked, and it shouldn't be, of course, all systems should come to an emergency stop. But if you have a muting scenario, whether there's a palm switch that somebody put their palm on to inadvertently make the light curtain mute or stop for a moment so you can reach in to grab the part, may then you have the robot programmed to be in another location. But if inadvertently the robot came towards your location while you have that muted, it will shut the system down. Those are things that you need to have in mind when programming these systems. When the light curtain is then tripped and it's supposed to have maybe a pallet going through and allow the system to operate, there's many different scenarios that can take into effect when it comes to muting. But again, all these are to take effect with the risk reduction and with the calculation of your assessment. Bypassing, typically when I've seen situations of bypassing is, say a pallet passed through and there was an extra box hanging off the end of the pallet. Maybe it might have made a bad pallet pattern. It would trip the light curtain because it didn't expect for the light curtain to be blocked at that specific second. There would be an operator intervention that there's nobody in the cell. The system start up and you'd have to hold a momentary switch while you then jogged the pallet through. Those are situations where you could deem bypassing as effective. Then, of course, you have your different safety devices that we talked about, such as the line scanner, the dead man switches, the photo eyes, the e-stops, and things of those nature. So those are things that can take into effect. But parts of these calculations, as you can look into the table, is the reaching through the openings. How far can the fingertip go? You know, how far past the knuckle? How far can the hand go in? These are all calculations that take into effect when it comes to doing these calculations. Now, we're going to jump a little bit from a lot of this talked about mainly the industrial robots, or may call the traditional robot. Yes, cobots are industrial robots, but a lot of people say cobot, industrial bot when we're talking about this in this world. But what makes a collaborative robot safe versus a conventional robot? Well, the core standards comply with that ISO 10566, basically because the power and force torque limits are much lower. They're not to exceed these certain safety limits. There are times that you can program a cobot to go outside those safe parameters if you were to put a line scanner in, so you can allow it to move much faster. But when someone comes into the vicinity of the cobot then slows down or even comes to a stop. It all depends on what you and your team deem safe based off the calculations of what do we do. So those are things that take an effect. Sometimes the robot may halt to immediately and fault because nobody should be in that area. These are things you take into account. These are all things that you would program in the safety system of that cobot. Another one is speed limits. The robot's programmed to avoid moving at speeds that could cause injury or collision with a person. Typically, you want to have that robot to where it's always from the shoulders down. If there's ever a time where the robot has to operate above the head, then and someone enters that cell, that robot should stop immediately. Just because you have a cobot and you give it a sharp object, it's not a cobot anymore. And you may need to put a safety fence around that robot or put a line scanner in to say, hey, somebody's within the vicinity of 10 to 15 feet of that robot, it then comes to a stop. These are all things that you must take into effect. The next one is safety rated stop modules, safety rated stop modes. Cobots are equipped with various stop modes that activate the robot in a safe event as an emergency stop. That usually with an emergency stop are designed for critical stops. Something isn't of an emergency. And we'll talk about the end of the slide versus or end of this webinar when it talks more about, do we do an emergency stop or do we do a cycle stop in a controlled environment? Obviously, if somebody breaks the plane of a safety or opens a door while the unit's running, which are complete no-nos unless it's an emergency. And I see this time and time again with industry that operators are just opening the door up and allowing the robot to come to immediate stop. Those are bad things to do. If you see there's a problem with the robot and it's not hurting human life, and say a slip sheet went out of place or maybe the robot loaded wrong, we should program things in like a cycle stop, which allows the deceleration of the robot to come to a stop, allows the brakes to engage properly. What happens is when you rip doors open or you do things that are an emergency situation, they're designed for emergencies. What they do is they put the brakes on immediately, and it could cause damage to your robot over time. It could make it drift out of its known position. You have to end up rehoming it. You wear the brakes out. There's a lot of things that could happen by continually just engaging the emergency stops while it's in motion. So those are things to take note of. The next one is speed separation monitor. Certain applications require additional safety sensors to detect human presence in the workspace, which involves, like we said, the line scanner. You can program that to where if nobody's around, it can run at a much faster rate. A person comes within the vicinity of the robot, it can run at a much slower rate. These are things that you could do with cobots that are a little bit more efficient when it comes to safety rather than a standard robot. Things to be in mind, as we talked about in the last slide, is that cobots do run at a slower rate inherently. And we're going to talk a little bit about how they're set up to where they're even safer to work around people. There are times where you can't use a cobot. You need the robot to run very fast. You need the robot to pick up very heavy objects at a very fast rate of speed. That's when you're going to have to go to a conventional industrial robot. But cobots do have their space, and I believe personally that you're going to see them pick up more and more as the years progress. Robots are also ergonomically designed. So beyond collision, cobots are designed in mind to prevent injuries. For instance, they're built to ensure that if a person's hand gets stuck between the robot joints, it's not going to cause them harm because each joint has a torque sensor, which you can even use in the automation of things. So those are also very exciting things to keep in mind. And lastly, so on my final thoughts, leaves a couple minutes for some questions on this one, is that when it comes to stopping the robot, now specifically, this is a FANUC teach pendant, there's a hold button. So UR, ABB, each one of them have different ways of doing this. You could even program into your cell a cycle stop button. So as the robot is performing its operation, you hit cycle stop, you want to program that robot to go to a home position. So if you have to remove something from the EOT, or do you have to maintain something, the robot is out of its way. You're not bothered by having to jog it out of its position. But when stopping the robot, pressing the hold button or cycle stop button will allow the robot to decelerate. Once it comes to a complete stop, then the brakes engage. You can open the door, open the interlock. when utilizing an e-stop, when I say e-stop, I'm also talking about safety devices such as light curtains and line scanners, because they should be wired into the safety system as like the e-stop was hit. These should only be used in emergency situations. And when you're doing that in non-emergency, well, actually, when you're doing that in emergency situations, yes, the robot does decelerate, but at the same time, the brakes are getting engaged, and you will wear those joints out. Those are things you don't want to do unless it's an emergency situation. So those are things to be aware of. And finally, our last slide is questions. So this time I did reserve 4 minutes for us to ask some questions. Let's see here. We got Dale that talks about, have you been teaching during your presentation? Will you send out presentation slides? Yes, the presentation slides will be sent out. Let's see here. A couple of those on presentation slides. Yep. So does anybody have any other questions? I know this is a good 1,000-foot level of the safety topics. Do not see anybody else asking questions. Again, if you guys need me to come in or have any other webinars that you want Tooling U to go over, contact Rose, contact Tooling U. We could definitely talk to you about your specific needs that you might have, whether if it's from robot applications or talking about safety. But I do have a couple more minutes for questions if anybody has any. I guess there is none. So Rose, you want to take it from here?
Looks like we just got one in.
Oh, okay. Could you speak more on the torque sensors for safeties with cobots? Yeah, so when it comes to, and I'm going to speak specifically to UR because I know these ones very well, actually, and FANUC too. So the torque sensors that are built into each system, first of all, they know when they're hitting a human or when they're going down and pressing against an object. You can utilize a torque sensor when it comes to UR specifically to say, if I need to pick up, say, this water bottle, and I don't know the weight of it, and say this water bottle weight, like, I don't know, 5 kilograms. When the robot goes down, these are things we're not going to talk about in this webinar, but each robot has a payload. And when it goes to pick up a payload capacity, the robot needs to know, based on the torque and the acceleration and deceleration, what is it picking up? So you can actually program the UR to come down and pick up this water bottle and move about, like, say, 30 millimeters, and based upon what stress went on that sensor, it could then calculate the weight of its picking up and then continue to do its task. So those are different things that can be done. The cobots are also programmed in a way to where, as it's going to push down and it feels resistance from the other way, it knows at that point, I'm hitting a safety violation, and then will stop. So I'm hoping that answered your question. But that's how they use the torque sensors on these robots. And you can also do different commands with these torque sensors. But again, these are things that you need to take into effect when you're doing the risk assessment. Is this safe if someone were to be in there? What other things and parameters I need to take in place? I would recommend, even when you're using a cobot and you feel as though it's in a safe environment, I still would always recommend putting a safety line scanner in place. Even if it was a small palletizing or some kind of buffing application, I would recommend that, because you have that device there to be extra on the cautionary side of safety, because that's always important when it comes to robotics. Hopefully I answered your question, Leon. Anyone else? All right. Well, it's great talking to you guys, and we shall see you next week for maintenance and troubleshooting. Hope you all have a great week.
Thank you, Herb.
Thanks. Have a great day, guys.